is Janet and Rabia.
Welcome to Everest Physics Academy.
Before we start, we'd like to recommend our Everest Physics books for high school.
Where you can find more explanations and solve applications and problems.
This exercise is about the motion of two particles A and B. We are going to calculate the instant at which the velocity of A is parallel to the x-axis. Prove that the velocity of A could not be parallel to the y-axis. Prove that the motion of A is decelerated during the time interval 0, 1.25 seconds. Determine the trajectory equation of B. Determine the position vector of B. Prove that A and B do not meet during their motion.
This exercise studies the motion of two particles A and B. Let's start with the motion of particle A. Particle A moves in xy plane. Its position vector is given by RA equals 5ti plus 10t squared minus 25tj in SI units. This animation shows the trajectory of particle A during the first 4 seconds. Number 1. Determine the expressions of the velocity and acceleration vector of A. Given that if x equals at, where a is a constant, then the time derivative of x equals a. And if x equals at to the power n, where a and n are constants, then the time derivative of x equals nat to the power n minus 1. We know that the velocity vector is given by the time derivative of the position vector, but r has the form of xi plus yj. X equals 5t, then the time derivative of x equals 5, and y equals 10t squared minus 25t, and the time derivative of y equals 20t minus 25. So v equals 5i plus 20t minus 25j in SI units, and the acceleration vector is given by the time derivative of the velocity vector. V has the form of vxi plus vyj. The time derivative of vx equals 0 and the time derivative of vy equals 20, so a equals 20j in meters per second squared. Number 2. Determine the instant at which the velocity of A is parallel to the x-axis. When the velocity is parallel to the x-axis, that means it has no component along the y-axis, so Vy equals 0. But Vy is given by 20t minus 25. So replace Vy by 0, then 0 equals 20t minus 25. This is going to be t equals 1.25 seconds.
Let's move to part 3. Could the velocity of A be parallel to the y-axis? Justify your answer. The velocity is parallel to the y-axis if its x component is 0. The x component of the velocity is 5 meters per second. It is different from 0. Therefore, the velocity could not be parallel to the y-axis. Part 4. Prove that the motion of A is decelerated during the time interval 0, 1.25 seconds. A motion is decelerated during a certain time interval if the dot product of the velocity and the acceleration is negative during this time interval. Now, replace v by its expression and a by its expression. Remember that I dot I equals 1, j dot j equals 1, I dot j equals 0. Let's start. 5i dot 20j equals 0 because I dot j equals 0. 20t minus 25j dot 20j equals 20t minus 25 times 20. Therefore, v dot a equals 400t minus 500, and it is expressed in SI units. Now we want to find the instant at which v dot a is 0. This is going to be 0 equals 400t minus 500, then t equals 1.25 seconds. Now choose a value of t in the time interval 0, 1.25 seconds. Let's say t equals 1 second. Replace t in the expression of v dot a by 1 second. The answer is minus 100. The answer is negative. Therefore, A dot V is negative for any value of t in the time interval 0, 1.25 seconds. Then the motion is decelerated during this time interval.
Now, let's study the motion of particle B. In addition to the trajectory of A, the shown graph shows the trajectory of particle B, which is drawn with the blue color, and the abscissa of particle B is given by 2t in SI units. Number 1. Use the graph to determine the trajectory equation of B. As you see, the trajectory of B has the form of a straight line. So, its equation is given by y equal ax plus b, where a is the slope, and the slope is given by delta y over delta x. To determine the slope, we have to take 2 points from the trajectory of B. Let's take the first point of coordinates 0, 10 and the second point of coordinates 5, 0. So a equals 0 minus 10 over 5 minus 0, which is equal to minus 2. Now let's determine the value of B. To determine the value of B, we take 1 point from the trajectory of B. Let's take the point of coordinates 0, 10. Now replace y by 0 and x by 10 in this expression. So 10 equals minus 2 into 0 plus b, then b equals 10 meters. Therefore, the equation of the trajectory of b is given by y equal minus 2x plus 10 in SI units.
Focus, please. This is important.
Let's move to part 2. Determine the expression of the position vector of B. Generally, the position vector is given by this expression, xi plus yj, where x and y are the parametric equations and they are functions of time. Here we have x as a function of time. And here we have y as a function of x. But we need y as a function of time. Then let's replace x in the expression of y by 2t. This is going to be y equals minus 2 times 2t plus 10. Therefore, y equals minus 4t plus 10. Now we are ready to write the expression of the position vector. It is 2ti plus minus 4t plus 10j, and it is expressed in SI units.
Intersection of the two trajectories. Number 1. Use the graph to indicate the coordinates of the point of intersection of the two trajectories. Look at the curves. These two curves intersect at a point having an abscissa 10 meters and an ordinate minus 10 meters. We proved that in the previous slide, the two curves of A and B intersect at a point having an abscissa 10 meters and an ordinate minus 10 meters. The question now, do the particles really meet? Justify your answer. To prove that whether these two particles meet at this point or not, we have to determine the time needed by each particle to pass through this point. Let's determine the time needed by particle A. The abscissa of particle A is given by 5t, so replace x by 10 meters, then the time needed by particle A to pass through this point is equals to 2 seconds. Now let's determine the time needed by particle B to pass through this point. Now replace x of B, which is equal to 2t by 10 meters, then the time needed by B to pass by this point is equal to 5 seconds. Since the time of A does not equal the time of B, that means the two particles do not meet at this point.
Now observe the motion of A and B. Both particles pass by the point of coordinates 10 minus 10, but not at the same time. So A and B do not meet during motion.
Thank you for watching. If you like this video,
Subscribe to the channel, hit the like button, and share.